Alright, in this video, this is part 3 of our lesson on graphing rational functions, where we're really just getting into everything, including slant asymptotes, holes, continuous versus discontinuous, removable, non-removable, the whole shebang. Alright, let's take a closer look. It will probably be easiest to look at the horizontal asymptote first. Because the degrees are the same, the horizontal asymptote will come from the leading coefficients. So that's 1 over 3. Alright, so that's why for the horizontal asymptote I'll have y equals 1/3. Alright, don't forget the y equals part. So that means there will be no slant asymptote. So I'll say none. For a slant asymptote, the top degree has to be 1 higher, and that's not the case. Now it's time to talk about vertical asymptotes and holes. For that, we need to factor and see if anything cancels out. If I factor the numerator, I see a common factor here. So I've got f of x equals. So the numerator is going to factor as x times x minus 4. Alright, we also have a GCF down here of x. Okay, so that's going to give me x times 3x minus 1. Okay, now normally we would take a look at these two factors in the denominator, and we'd be thinking about vertical asymptotes, and so we set these factors equal to 0. So that would give me x equals 0, and that's already kind of done, and this would give me 3x minus 1 equals 0. Now this one we would have to add 1 to both sides, So that's going to give me 3x equals 1. And then I would need to divide both sides by 3. I apologize for my croaky voice, by the way, guys. But I can't sleep. It's like I have insomnia right now, which is weird because I don't get much sleep. So normally I can't wait to sleep. But it's 2:42 a.m. on, I guess it's technically Saturday morning, Friday night, Saturday morning. But I couldn't sleep, so I got up to make this video. But my voice, even though I'm awake, my voice isn't awake, if that makes any sense. Anyway, so I'm getting x equals 1/3 and x equals 0. Are they both vertical asymptotes? No. The reason why they're not is because, see these two x's? These are going to cancel out. And when factors cancel out, that gives you a hole instead of a vertical asymptote. So here that tells me I'm going to have a hole at 0 comma something. This will in fact be a vertical asymptote. Okay, so fine. So I have a vertical asymptote at x equals 1/3. Alright, very much like my horizontal asymptote. So x equals 1/3. Now I have a hole at 0 comma something. I need the y value. To get the y value, I am going to put this part of the function in my calculator. X minus 4, 3x minus 1. Okay. Now, okay, yeah, it's 0 comma something, so let's go ahead and look at 0. Alright, I think I'll just leave it on auto for now. So 0 comma 4 is my hole. Alright, let's graph what we have so far. Let's graph the two asymptotes and the hole. Okay, so here are the asymptotes at 1/3 and 1/3. And here's my hole at 0 comma 4, y-intercept. Alright, and so graph your hole as an open circle. Alright, and let's just continue to look at the table for some other values. Okay, for example, let's see what's happening at -1. So at -1, I've got this. That's 1.25. Okay, don't be stingy with your points, people. Alright, so at -1, I've got 1.25, so that'll be about here. Okay, let's see what's going on at, well, let's look at -2. Okay, that's 0.8, 0.9, it's a little bit below 1. So that's already like right here. Okay, so that's enough information. I see what's happening here. Okay, so that's going to look a lot like that. Let's see what's going on over here. So let's look at 1, positive 1. Okay, so that's -3/2. I know that's -1.5. So 1 comma -1.5. That'd be like right here. Okay, normally I like to do decimals on the left and right, but because the asymptote itself is between the lines, this is less than 1 away, so that's good enough. Let's look at what's going on at 2, but I'm betting it's going to be like up here somewhere. Okay, it's -2/5, which is like -0.4. Okay, so that's like about here. Alright, so I can already see what's going on here. It's doing this type of a deal. Okay, so your graph should look very much like that. Now, normally we would say for the domain, we just go -infinity to 1/3, 1/3 to infinity. But if you look closely, the whole separates this branch into 2 pieces. So you really will have 3 parts to your domain. We'll have to say -infinity to 0, okay, that's the x value here, and then 0 to 1/3. Okay, it's this, that captures this little piece right here, and then we'll do the other branch. So so again, -infinity to 0, because that's the whole. Okay, that's the 0 right there, and then we'll pick up from there and we'll say 0 to 1/3. Okay, because that's my vertical asymptote. So now I'm here, and then now I'm going to do this part, which is 1/3 to infinity. Okay, so 3 parts to that domain. Obviously this is not continuous, alright? Continuous means unbroken, and this has 3 different pieces to it. And so we have a removable discontinuity, okay, which is the, you're right, that's a point discontinuity, and the point is 0, 4. We also have a non-removable discontinuity. Alright, that's called infinite. Okay, and these when I say non-removable discontinuity, I'm talking about, hold on. Alright, if you have a jump or if you have an asymptote. So in this case we have asymptote. So asymptotes are called non-removable discontinuities. And we have 2 of those. So our x equals 1/3 and our y equals 1/3. Okay, so that is it for problem number 3. Okay, let's go ahead and get problem number 4 in the same video. Alright, for problem number 4, let's go ahead and do the horizontal asymptote first. Again, we look at the degree. Since the top degree is lower than the bottom degree, that tells us that the horizontal asymptote will simply be y equals 0. Now, so that means there won't be a slant asymptote. So I'm just going to put none. A slant asymptote will happen when the top degree is higher by 1. But that didn't happen. So now let's talk about vertical asymptotes and holes. To consider those, we need to factor the denominator for sure. So this is going to become, so I've got my x minus 1, but my denominator is x plus 1 times x minus 1. And normally, like in the past, we would take these two factors and set them equal to 0 to find the vertical asymptotes. Okay, so here I would subtract 1 from both sides. Here I would add 1 to both sides. So that would give me x equals negative 1. And that will give me x equals positive 1. And under certain circumstances, I would have 2 vertical asymptotes. However, I will not have 2 vertical asymptotes this time. The reason why is because, see this x minus 1 up here? Alright, so I have an x minus 1 in the numerator and denominator. In a sense, those will cancel out. For that reason, this x equals 1 is not a vertical asymptote. Alright, instead, this is going to give me a hole. Alright, there will be a hole at 1 comma something. But this over here that didn't get canceled out, this is a vertical asymptote. Okay, so I have a vertical asymptote at x equals negative 1. I have a hole at 1 comma something. I need to know the y value. I can find that by typing this function into the calculator without the parts that we would cancel out. Okay, otherwise we'll just have an error there because it's undefined. So consider this to be a 1 up here. So this is what I'm going to type into my calculator. 1 over x plus 1. Alright, and we want to know what's happening at an x value of 1. So might as well start at 1. Okay, so that's 1/2. Okay, 1 we got. So 1 comma 1/2. So let's go ahead and graph the asymptotes and the hole. Alright, so there are the asymptotes at negative 1 and 0. Okay, my vertical and horizontal asymptotes. Now I have a hole at 1 comma 1/2. Okay, so here's 1 and then up 1/2, so that'll be right in the middle. Okay, let's get a couple more points going. Alright, so looking back at the calculator. Okay, so let's see. So what's happening at 0? At 0, we are at 1. So we have 0 comma 1 is a point. Let's see what's happening at, I always like to look at a decimal to the left and right of the asymptote. So let's see what's going on at negative 0.5. To do that, I'm going to switch to ask mode real quick. Okay, so negative 0.5 gives me 2. Alright, so here at negative 0.5, I'm up here at 2. Alright, these 3 points, including the hole, give me enough of an idea what's going on here. Alright, make sure you don't draw through your hole. Just leave it a hole. Okay, so that branch is going to look something like that. Now this branch over here, so let's see what's happening. Let's get that decimal in there. So negative 1.5, let's check it out. Okay, so negative 1.5. Okay, that's negative 2. So negative 1.5 is at negative 2. How about negative 2? Okay, that's at negative 1. So at negative 2, we're at negative 1. All right, one more. How about negative 3? Okay, that's negative 1/2. So at negative 3, I'm down halfway. All right, and that's plenty enough to show me what's going on here. Alright, so your graph should look like this. Now when you do the domain, be careful. You won't just have 2 pieces. You actually have 3. So for this branch, we will do negative infinity to negative 1, you know, the asymptote. So negative infinity to negative 1, union. But the other branch is in 2 pieces because of the point discontinuity. So we have to do the part on the left and the part on the right. So starting from the asymptote, so negative 1 to 1 will be the next piece. And the final piece will be from 1 to infinity. Alright, a continuous graph has no break in it, so this is definitely discontinuous. Let's see, but do we have a removable or non-removable discontinuities? Well, we learned in our notes that point discontinuities are removable, and all of the other kinds are non-removable. Okay, including if you have an asymptote, that's infinite, but it's non-removable. So we have point discontinuity and infinite discontinuity. So let's just list it. So we have infinite discontinuity. Wait, that's a non-removable one. So let me put it down here. So we have non-removable discontinuities. Okay, we have infinite because they're the asymptotes, which are at x equals negative 1 and y equals 0. So these are my non-removable discontinuities. Point discontinuity is considered removable. We do have one of those. All right, it is a point discontinuity, and specifically it is the point 1 comma 1/2 is the removable discontinuity. Alright, and that is it for problem number 4. Finally got 2 problems in one video. I've been doing like 1 problem per video and it's been taking the whole time. So hopefully at this speed I can at least do 2 problems at a time. That's it for this video though. I'll pick up the next video with number 5. Looking pretty ugly. I see some grouping coming though. Grouping. See you on the next video.